Okay, so we are now in topic 15, which is tides. So what are tides? Tides are the periodic motion of the waters of the sea due to changes in the attractive forces of the moon and sun upon the rotating earth. So tide is caused by the attractive forces or the gravitational pull of the moon and the sun. Tides are one of the most reliable phenomena in the world. As the sun rises in the east and the stars come out at night, we are confident that the ocean waters will regularly rise and fall along our shores. Okay, so why do we need to study tides? Tides are very long period of waves that move through the oceans in response to the forces exerted by the moon and the sun. Tides originate in the oceans and progress towards the coastline or coastlines, where they appear as a regular rise and fall of the sea surface. When the highest part, that is called crest, of the wave reaches a particular location, high tide occurs. And low tide corresponds to the lowest part of the wave, or it is called throw. The difference in height between the high tide and low tide is called the tidal range. Okay, the rise and fall of tides play an important role in the natural world and can have a marked effect on maritime related activities. So the image below shows the National Oceanic and Atmospheric Administration San Francisco Tide Station in operation for more than 150 years. No? So 150 years. Hanggang ngayon, luma pa rin ang itsura. Na? Until today. Okay, what are some of the maritime activities affected by tides? So loading and discharging are affected by tides. How is loading and discharging affected by tides? Do you have any idea? The tides, of course, it is rise and fall. It will also affect the loading and discharging because if the loading spout is near the top of the cargo hold, then during high tide, there is a possibility that the port cannot position the loading spout in your cargo hold. So that's why you are going to watch, as officers, you are going to watch the high tide and low tide. And of course, the information will also be given by the port authorities if you can load or not at that particular instant. Okay, another one is port watch because you need to watch your ropes, mooring ropes. So because of high tide and low tide, there is a tendency that your mooring ropes will snap, especially those with high tidal range, no? Yung more than 8 meters. So if it is more than 8 meters, then surely it is very dangerous for your mooring ropes. And then entrance to or passing a bar. For example, the Amazon River, there is a shallow bar there located at the mouth of the river. And that is where the vessels will pass. And a lot of vessels have run aground in that area because of this river bar. That's why you need to also to watch the height of tide. Another is entrance to a port, berth, wharf, or pier. Of course, entering a port, there is a channel. Sometimes it is only dredge, no? So sometimes a large vessel cannot pass unless it is high tide. So he must wait for high tide. For example, in Argentina, there is a port that you cannot go if you are at low tide. So you must wait for the high tide so that you can enter the port. And then another is anchorage. How is anchorage affected by tide? Of course, if the anchorage area is shallow, then there is a tendency of grounding. And also there is a tendency for the naabsa close. No? So naabsa means not always afloat but safely aground. Another is river or channel navigation. So river or channel navigation, of course, there are some areas that is shallow or that are shallow. So you need also to watch the time of passing. You must pass there during the high tide. And then hazard identification. For example, a wash rock. A wash rock, it means during high tide, you cannot see the rock. And during low tide, you can see part of it. So this is a dangerous hazard because you cannot see during high tide. And others, no? There are some more that are not so relevant for the maritime officer. Okay, what is a bar or a river bar? This is a ridge or mound of boulders, gravel, sand, and mud found along or in a stream channel at places where decrease in velocity causes deposition of sediments. However, in the Amazon River, the um, the stream channel, there is an increase of velocity of the water displaced. But the dangerous bar there is far away from the mouth of the river, but it is a channel that the vessels will pass going inside the Amazon River. So that is still dangerous. Okay, maritime activities throughout the world depend on accurate tidal and current information for safe operation. So the National Oceans Service or the National Oceanic and Atmospheric Administration's National Ocean Service collects, studies, and provides access to thousands of historical and real-time observations, as well as predictions of water level, coastal currents, and other data. Okay, so this is low tide and high tide. Okay, so this image during low tide, you can see the island, and during high tide, it is below the water level. Okay, so basically, tides are very long period of waves that move through the oceans in response to the forces exerted by the moon and sun. Tides originate in the oceans and progress towards the coastline, where they appear as a regular rise and fall of the sea surface. When the highest part or crest of the wave reaches a particular location, high tide occurs, and low tide corresponds to the lowest part of the wave, or it is called trough. The difference in height between the high tide and the low tide is called the tidal range. Okay, if you observe, there is a seaweed that is being carried by the water. No? So during flood tide or flood current, it comes near the shore because the water is also going up. And during ebb current, the water seems to go far away from the shore because it is actually lowering down to low tide. So the difference is called the tidal range. Okay, so this is another image. This is during high tide, and then the another one is during low tide. And the difference is the tidal range. Okay, so it is the same as the waves, which the highest part is the crest and the lowest is the trough. Okay, a horizontal movement of water often accompanies the rising and falling of the tide. This is called the tidal current. The incoming tide along the coast and into the bays and estuaries is called a flood current. Yung papasok, that is called a flood current. The outgoing tide is called an ebb current. The strongest flood and ebb currents usually occur before or near the time of the high and low tides. The weakest currents occur between the flood and ebb currents and are called slack tides. In the open ocean, tidal currents are relatively weak. Near estuary entrances, narrow straits, and inlets, the speed of tidal currents can reach up to several kilometers per hour. Okay, the gravitational attraction between the Earth and the Moon is strongest on the side of the Earth that happens to be facing the Moon, simply because it is closer. This attraction causes the water on this near side of Earth to be pulled toward the Moon. As gravitational forces or force acts to draw the water closer to the Moon, inertia attempts to keep the water in place. But the gravitational force exceeds it and the water is pulled toward the Moon, causing a bulge of water on the near side towards the Moon. So I will enlarge the image. Okay, so here you can see our planet Earth and the Moon. No? So the side facing the Moon, there is bulging of that is caused bulging of the water, no? That is caused by the gravitational attraction. And then on the other side also, because the Earth is also being attracted to the Moon, so lalapit siya, it will also cause a bulging on the other side. That's why there are two bulges. No? On the opposite side of the Earth or the far side, the gravitational attraction of the Moon is less because it is farther away. Here, inertia exceeds the gravitational force and the water tries to keep going in a straight line, moving away from the Earth, also forming a bulge. Okay, gravity and inertia act in opposition on the Earth's oceans, creating tidal bulges on opposite side of the planet. On the near side of the Earth, the side facing the Moon, the gravitational force of the Moon pulls the ocean ocean's waters toward it, creating one bulge. On the far side of the Earth, inertia dominates, creating a second bulge. Okay, so let me enlarge it. Okay, the tidal bulge due to less gravity than the Earth, than the center of the Earth. So it will cause also a bulge and also will cause high tide. And then the one facing the moon, tidal bulge due to greater gravity than the center of the Earth. So most coastal areas experience two low tides and two high tides every lunar day. So lunar day is equal to 24 hours and 50 minutes. And then as the moon's position changes, two tidal bulges rotate around the Earth. These bulges represent high tides, while the corresponding flat sides indicate low tides. So dito, no? Of course, the bulges are not steady, no? Kung saan yung moon, where the side facing it will be the one bulging and the opposite side also is bulging. So pag ikot niyan, iikot din to. Kung saan iikot yung buwan, iikot din yung bulge. Anyway, I have a video there that you will watch later. Of course, the video is not mine, but from a reliable source. Later, you must watch it to understand more about tides. Okay, in this way, the combination of gravity and inertia create two bulges of water. One forms where the Earth and Moon are closest, and the other forms where they are farthest apart. Over the rest of the globe, gravity and inertia are in relative balance because water is fluid. The two bulges stay aligned with the Moon as the Earth rotates. The Sun also plays a major role affecting the size and position of the two tidal bulges. The interaction of the forces generated by the Moon and the Sun can be quite complex, as this is an introduction to the subject of tides and water levels. We will focus most of our attention on the effects of the stronger celestial influence, which is the Moon. As we have just seen, the Earth's two tidal bulges are aligned with the positions of the Moon and the Sun. Over time, the positions of the celestial bodies change relative to the Earth's equator. The changes in the relative positions have a direct effect on daily tidal heights and tidal current intensity. Okay, as the Moon revolves around the Earth, its angle increases and decreases in relation to the equator. This is known as its declination. The two tidal bulges track the changes in lunar declination, also increasing or decreasing their angles to the equator. Similarly, the Sun's relative position to the equator changes over the course of a year as the Earth rotates around it. The Sun's declination affects the seasons as well as the tides. During the vernal and autumnal equinoxes in March 21 and September 23 approximately or respectively, the Sun is at its minimum declination because it is positioned directly above the equator. On June 21 and December 22, the summer and winter solstices, respectively, the Sun is at its maximum declination. That is its largest angle to the equator. So if you remember, the maximum declination is 23 degrees and 27 minutes. But today, if you observe the almanac, it is less. Hindi na niya naabot yung 23 degrees and 27 minutes. Okay, the Earth's tidal bulges track or follow the position of the moon and to a lesser extent, the sun. As the angles of these two celestial bodies in relation to the Earth increase and decrease, so do the tidal bulges. Here we observe the moon's changing declination to the equator and the effect that this has on the positions of the Earth's tidal bulges. Okay, the frequency of tides, the lunar day. Most coastal areas, with some exceptions, experience 2 high tides and 2 low tides every day. Almost everyone is familiar with the concept of a 24-hour solar day, which is the time that it takes for a specific site on the Earth to rotate from an exact point under the sun to the same point under the sun. Similarly, a lunar day, also known as the tidal day, is the time it takes for a specific site on the Earth to rotate from an exact position or exact point under the moon to the same point under the moon. So, ibig sabihin, pag ikot niya, under the moon, tapos umikot ulit, you're under the moon again, that is called lunar day. And unlike a solar day, however, a lunar day is 24 hours and 50 minutes. The lunar day is 50 minutes longer than a solar day because the moon revolves around the Earth in the same direction that the Earth rotates around its axis. So it takes the Earth an extra 50 minutes to catch up to the moon. Okay, because the Earth rotates through 2 tidal bulges every lunar day, coastal areas experience 2 high and 2 low tides every 24 hours and 50 minutes. High tides occur 12 hours and 25 minutes apart. It takes 6 hours and 12.5 minutes for the water at the shore to go from high to low or from low to high. Okay, unlike a 24-hour solar day, a lunar day lasts 24 hours and 50 minutes. This occurs because the moon revolves around the Earth in the same direction that the Earth is rotating in its axis. Therefore, it takes the Earth an extra 50 minutes to catch up to the moon. Since the Earth rotates through 2 tidal bulges every lunar day, we experience 2 high and 2 low tides every 24 hours and 50 minutes. So here we see the relationship between the tidal cycle and the lunar day. High tides occur 12 hours and 25 minutes apart, taking 6 hours and 12.5 minutes for the water at the shore to go from high to low and then from low to high. Okay, so the animation is shown from the perspective of a viewer in the northern hemisphere. So from a viewer in the southern hemisphere, the rotation would appear to go clockwise. So that is the animation. Ito. Okay. Okay, influence of the moon and the sun. The moon is a major influence on the Earth's tides, but the sun also generates considerable tidal forces. Okay, solar tides are about half as large as lunar tide and are expressed as a variation of lunar tidal patterns, not as a separate set of tides. When the sun, moon, and earth are in alignment at the time of the new or full moon, the solar tide has an additive effect on the lunar tide, creating extra high high tides and very low tides, both commonly called spring tides. 1 week later, when the sun and moon are at right angles to each other, the solar tide partially cancels out the lunar tide and produces moderate tides known as neap tides. During each lunar month, two sets of spring tides and two sets of neap tides occur. So anyway, if you watch the video later, it will be explained clearly. No? Okay, neap tides, and then it will go spring tides, and at right angles, neap tides again, and at inline, spring tides. So just remember, if it is at right angles, the bulges at right angles, or the moon, it is called neap tides. And when it is aligned with the sun, either in the near or opposite direction, then it is called spring tides. So madaling tandaan. No? Just as the angles of the sun, moon, and earth affect tidal heights over the course of a lunar month, uh, so do their distances to one another. Because the moon follows an elliptical path around the earth, the distance between them varies by about 31,000 miles over the course of a month. Once a month, when the moon is closest to the earth, this is called the perigee, tide generating forces are higher than usual, producing above average ranges in the tides. About 2 weeks later, when the moon is farthest from the earth, at apogee, the lunar tide racing force is smaller, and the tidal ranges are less than average. A similar situation occurs between the earth and the sun. When the earth is closest to the sun, it is called perihelion, which occurs about January 2 of each calendar year. The tidal ranges are enhanced. When the earth is farthest from the sun, that is called aphelion, around July 2, the tidal ranges are reduced. I know you already encountered these terms, no? Yung apogee, perigee, apogee, uh, perihelion, and aphelion, which is in your celestial navigation. When the moon is nearest the earth, it is called perigee. So, para hindi mo mapagbaliktad, peri is near very. So, very near. No? And apogee is malapit-lapit sa word na afar. Afar, no? So, kung titigasan mo, apar, which is pareho silang up, no? Apogee and afar, mas malayo. Ganon din yung the position of the sun and the earth. Kung nearest yung orbit nila, then it is called perihelion. Ganon din. The word peri, pwede mo sabihin na very near. So yun ang palatandaan namin no, dati during our reviews, and I think way back in college yata parang tinuro na rin. Okay, types and causes of tidal cycles. Diurnal, semi-diurnal, and mixed semi-diurnal, or called continental interference. Okay, if the Earth were a perfect sphere without large continents, all areas on the planet would experience two equally proportioned high and low tides every lunar day. The large continents on the planet, however, block the westward passage of the tidal bulges as the Earth rotates, unable to move freely around the globe. These tides establish complex patterns within each ocean basin that often differ greatly from tidal patterns of adjacent ocean basins or other regions of the same ocean basins. So the large continents is blocking the bulges. That is why tidal cycles are different in different parts of the world. But as it is said, if the Earth were a perfect sphere, all areas on the planet would experience two equally proportioned high and low tides every lunar day. Okay, there are three basic tidal patterns occur along the Earth's major shorelines. In general, most areas have two high tides and two low tides each day. When the two highs and the two lows are about the same height, the pattern is called a semi-daily or semi-diurnal tide. If the high and low tides differ in height, the pattern is called a mixed semi-diurnal tide. Some areas such as the Gulf of Mexico have only one high and one low tide each day. This is called a diurnal tide. The US West Coast tends to have mixed semi-diurnal tides, whereas a semi-diurnal pattern is more typical of the East Coast. Okay, so we have an image here with legends. No? So red is semi-diurnal tides, yellow diurnal tides, and the blue or the purple is the mixed semi-diurnal tides. So almost all over Africa is semi-diurnal tides. And also the UK and in Europe. No? But in the Mediterranean, along Africa is semi-diurnal, but along the European coast, mixed semi-diurnal tides. So, hindi klaro yung ating Philippines dito. But we have also mixed semi-diurnal tides. Okay, diurnal tide cycle. An area has a diurnal tide cycle if it experiences one high and one low tide each lunar day. Many areas in the Gulf of Mexico experience these types of tides. So during the lunar day, 24 hours and 50 minutes, so aakyat siya ng isa and then bababa siya ng isa. No? And then the semi-diurnal tide cycle. An area has a semi-diurnal tide cycle if it experiences two high and two low tides of approximately equal size every lunar day. Many areas on the eastern coast of North America experience these tidal cycles. So this is one lunar day, which is 24 hours and 50 minutes. So bababa siya ng isa, aakyat siya ng isa, and then bababa siya ng isa ulit. Not exactly equal, pero malapit-lapit. No? And then aakyat siya ng isa ulit. So dalawa. Tegalawa, no? Two high tides and two low tides. Okay, and then the mixed semi-diurnal tide cycle. An area has a mixed semi-diurnal tide cycle if it experiences two high and two low tides of different size every lunar day. So many areas of the western coast of North America experience these tidal cycles. Okay, so bababa siya lang sobrang baba, tapos aakyat siya lang hindi masyadong mataas, tapos bababa siya ng hindi ganun kababa, and then aakyat siya ulit ng sobrang taas. So that is mixed semi-diurnal tide, which has two high and two lows of different sizes. Okay, other factors that affect tides. The relative distance and positions of the sun, moon, and earth all affect the size and magnitude of the earth's two tidal bulges. At a smaller scale, the magnitude of the tides can be strongly influenced by the shape of the shoreline. When oceanic tidal bulges hit wide continental margins, the height of tides can be magnified. Conversely, mid-oceanic islands not near continental margins typically experience very small tides of 1 meter or less. The shape of bays and estuaries also can magnify the intensity of tides. Funnel-shaped bays in particular can dramatically alter tidal magnitude. The Bay of Fundy in the Nova Scotia is a classic example of this effect and has the highest tides in the world, over 15 meters. No? So I have said before, no, yung highest, which is more than 16.3 yata, if I remember correctly, no? Which is found here in the Bay of Fundy in Nova Scotia. Okay, narrow inlets and shallow water also tend to dissipate incoming tides. So inland bays such as Laguna Madre in Texas and Pamlico Sound in North Carolina have areas classified as non-tidal even though they have ocean inlets. In estuaries with strong tidal rivers such as the Delaware River and the Columbia River, powerful seasonal river flows in the spring can severely alter or mask the incoming tide. So hindi maramdaman yung tide because of yung seasonal river flows. No? So Columbia River is in, if I'm not mistaken, in Portland, Oregon. If I'm not mistaken, or if I remember correctly. Sa dami kasi na napuntahan ko, minsan makalimutan ko na yung mga pangalan ng ilog. Okay, local wind and weather patterns also can affect tides. Strong offshore winds can move water away from coastlines, exaggerating low tide exposures. Onshore winds may act to pile up water onto the shoreline, virtually eliminating low tide exposures. High pressure systems can depress sea levels, leading to clear sunny days with exceptionally low tides. Conversely, low pressure systems that contribute to cloudy, rainy conditions typically are associated with tides done as much higher than predicted. So these are the other factors that affect tides. Okay, so that's it for today. We will continue tides next meeting, and probably we will have our last quiz. Okay, so thank you for listening. I will end this meeting.